Hello there. My presentation project title is Digital Data Defines the Future, Reinventing Supply Chains at Supply Next Limited. Myself, is Istiak Sikder Hadi. I'm currently pursuing my BBA in Port Management Logistics in Bangladesh Maritime University. So, in this presentation, I'll take you through how Supply Next Limited, a rapidly growing manufacturing company, can transform its entire supply chain through Industry 4.0 technologies, combining AI-driven forecasting, IoT-based tracking, and a unified namespace architecture. We'll move step by step, first identifying what's not working, then exploring the digital architecture that fixes those inefficiencies, and finally, understanding the measurable benefits of the transformation. So, in the screen, you can see in the first section, supply next biggest challenge lies in the growth outpacing its infrastructure. So note this, supply next is a made up company so that I can uh, explain you the problems and solutions. So the company faces forecasting errors, delivery delays, and poor data visibility because its departments operate in isolation. To address this, I have proposed an integrated Industry 4.0 transformation centered around AI forecasting for smart planning, unified namespace (UNS) for full visibility for real-time collaboration, and LoRaWAN based industrially IoT for full visibility and tracking. Together, these create a supply chain that is connected, intelligent, and predictive, rather than reactive and fragmented. So, let's analyze the current situation. Um, so As you can see here, there are four major problem zones: production delays, inventory mismatches, delivery delays, and wasted inventory. So each one stems from disconnected systems, factories, warehouses, and retailers can't share information instantly. This causes what we call data silos, where one department never truly knows what another is doing. Now, let's break down each of these four problem areas visually. Here you can follow the arrows between sales and production. They represent how single inaccurate forecast throws off the entire chain. Overproduction, creating surplus goods, wasted motion, and tied up capital. And underproduction, leading up to idle machines, missed sales, and wasted capacity. These diagram clearly shows that forecasting based on old data cannot survive in a fast-changing market. Then let's see inventory mismatches. That's interesting. So you can see the diagram, right? So in this diagram, you'll see like three things. There's upstream effects, there's factory level effects, and there is downstream effects. So I'm gonna explain what are these, and you can see the like diagram too, so that it helps you. So upstream, the red triangle shows the bullwhip effect, erratic procurement due to distorted demand signals. Factory level, symbolized by the gear. We see frequent schedule changes and low utilization. Downstream, represented by the downward arrow. Retailers experience purchase order delays and stockouts. So these arrows trace the ripple effect. After a disconnected system creates throughout entire the supply chain. So let's go to delivery delays. Yes. So you can see that this section shows the impact of missing IoT integration. Look at how the arrows break the flow between production and logistics. So obviously there are here you can see there are upstream effects and there is downstream. So upstream logistic doesn't get production readiness signals. Factory level goods are ready but not digitally tagged, so they can't be tracked. Downstream, these result in shipment cancellations, reverse logistics, and lost trust. The visualization demonstrates one crucial truth. Without IoT visibility, supply next can't ensure on time in delivery. So let's go to wasted inventory. So um, You can see here we can see wasted inventory, supply chain blind spots. So notice how inefficiency loops back on itself. Raw material waste upstream, misalignment in production midstream, and back orders downstream. So this repetitive loop is exactly what happens when real-time unified data is missing. So here it comes, the big idea, implementing Industry 4.0. Now, here's where the transformation begins. As you can see in the architecture, as you can see in the architecture visual, Industry 4.0 connects every function through cyber physical systems, IoT, and cloud computing. At the center is the UNS. You can see that at the center there is unified namespace, the digital backbone. It replaces isolated hierarchical control systems with a continuous event-driven network. So this allows supply next ERP, MES, WMS systems to speak one common digital language in real time. Through this integration, the company evolves from a reactive structure to a proactive intelligent ecosystem. AI-driven forecasting. So you can see the AI-driven forecasting. Uh, you can see here. So this diagram shows how XGBoost, a high accuracy AI algorithm, powers the new forecasting system. Data flows in from multiple sources, uh, like sales and inventory, and external sources like market trends and seasonality. The AI model learns complex relationships and outputs a highly accurate demand forecast. So that forecast is then published to the unified namespace where all the connected systems like production, warehousing, logistics automatically adjust their schedules. So this creates a self-learning loop that continuously improves forecast accuracy. So, so like now we have to like integrate it, right? So um, to like um, integrate it is we have to thought we have to think logically, like we can't just say anything. So it's very much technical but it's very much interesting too. So here in UI Davis section, you can see this. At the core you will see MQTT broker surrounded by systems ERP, MES, WMS, and dashboards. So these arrows show bidirectional communication. Every department posts, sends, and receives live data updates. No more manual updates or missing information. This single structure eliminates silos and ensures every part of the business moves in sync. IIoT tracking with Laravel. So you can see, so these diagrams show LoRaWAN based IoT tracking brings real-time visibility to every stage. We can see three layers. Factory floor, asset tags, factory floor asset tags, bin sensors, tags, stock and location. In warehouse, pallet trackers and door sensors come from shipments. Sorry. And transportation, GPS and environment sensors track delivery routes and conditions. All these data travels wireless to LoRaWAN gateways, then to the network server, finally into unified data space. This completes the loop between physical movement and digital visibility, the essence of Industry 4.0. So basically, now the real-time dashboard with Grafana. So what's Grafana? This flow diagram shows the real-time dashboard built with Grafana using Telegraph and Influx BDS connectors. The sequence is sensors, unified namespace, Telegraph, Influx DB, and then Grafana. Grafana turns raw data into live visuals, showing machine performance, stock levels, and delivery progress. So within this, the distribution requirements planning (DRP) modules uses real-time inputs like demand, safety stock, and lead times to decide what needs to go where and when. So this gives managers complete visibility and control, all through a single interface. Oh, like obviously, if we implement, there are like benefits. So when I'm explaining this, I'm explaining by showing you the diagram because I'm explaining it on my web. That by explaining to seeing the diagram is easy for me too. So benefits of the transformation, like obviously faster deliveries and faster delivery. means transparency reduces stockouts and delays, lower costs and waste, accurate forecasting prevents excess production, improved team coordination, shared real-time data keeps department aligned, and lastly, higher customer service. That is very, very important. Better product availability and timely deliveries build trust. So this transformation turns supply chain into a modern data-driven organization, ready to compete at global standards. So we can't just jump at something without starting it small. Here, notice how the diagram narrows. It symbolizes a pilot first approach. The company can begin small, run the AI model on one product, connect the one warehouse zone to the UNS, deploy LoRa WAN devices in limited area. Once proven effective, each solution can scale gradually, minimizing risk while maximizing value. Conclusion. So we have come to the conclusion. And finally, by adopting Industry 4.0, supply estimated can be the next game changer. It is existed, but it isn't implemented. Subliners can transition from reactive operations to predictive data-driven excellence. With AI forecasting, unified data flow, IoT tracking, the company ensures faster deliveries, reduced waste, and better coordination, and long-term customer trust. So this isn't just digitalization; it's a complete reinvention of how supply chain thinks, connects, and delivers. Thank you for watching. If you're interested in this project or want to collaborate with me, feel free to reach out to Istiak Sharafat at gmail.com. That's about it. Thank you.